Alright, pyramids and cones and surface area is what we're doing today. So what are we doing today? Surface area with pyramids, and cones. We're going to start out by just doing some labeling. We're going to label first, and then we're going to find the both lateral area and the total surface area. So that's kind of the way that we're setting this up step by step. First series of problems are just going to be labeling, though. So that's what we're going to start with. So let's do that. We got oh, by the way, we're going to label the net. That's what we're doing, because this is a net. We're going to label that with the information that we have. So let's start with these pieces here. So I look at the circle, and I notice that I have a radius, and it's 13, so I'm going to go down to this circle, and that's a radius of 13. Now if I were to take and unfold this cone into a flat shape, it would look like this piece here that's being rotated around. So the pieces that we know of that are this slant height, the 30. Let's underline that in blue. The slant height 30. So it's going to be 30. That also means that this piece here is 30. And if I wanted to find the areas of each one, well, this area of the circle is just going to be pi times 13 squared, pi r squared. And here, the area of this kind of thing, it has to do with a sector, but it's really just pi times the radius, which is 13, times this length of the circumference, that portion of the circumference, which happens to be 30. Oh, I'm not even thinking correctly here, but it's just pi times 13 times 30. It's that easy. Super easy. Let's do it again. Number 2. So if we were to take this pyramid and unfold it, we actually have kind of a square bottom, and then these 4 triangles are going to all be congruent. So just so you know that we're looking at all 4 of these triangles are congruent, then these inside pieces of the square are also congruent. So that's 20, and so are all those other ones. And then these sides here, we don't know what those are, but we do know this slant height. I like coloring the slant height blue, so I'm going to redraw it blue here so you guys can see that. I like to color it blue. That's 26. So is this one as well. That's 26. And so are these. So we got plenty of numbers here to make our way around. And realize that this just splits up into a square and 4 triangles. We can find the areas of those and add them up. We'll be doing that kind of stuff later. Number 3. We got a slightly different shape, this time a pentagon. So I have this weird looking piece here. I'm going to color it in purple, the color purple. I'm going to recolor it purple up here as well. It goes from the center out to an edge, and that's actually called an apothem. So that right there is called the apothem. That helps us calculate the area of a regular polygon. This happens to be a regular polygon where all sides are 13. So that's 13 here, as well as here, and here, and here, and here. By the way, that apothem, we were told, was 8.9. And then this slant height that we see going on here is, there we go. Okay, that's going to be 21.9, and that's congruent all the way around as well. So each of those is 21.9, 21.9, and so on. Cool. So we're just labeling. We got our pieces labeled. We use the numbers, but we put them on the 2-dimensional flat figure. Let's do it again. Number 4. Alright, now this one's a little bit different because this bottom is not regular. Not all the sides are the same. But I noticed that 2 of them do look pretty close to each other. So when I notice that those 2 look pretty close to each other as 18, I'm going to go ahead and mark those. See, we have 18 and 18. That looks like these 2 sides here. So that's 18 and 18. And then this side here would be 12, that shorter side of the triangle. The thing that's not given to me is the 12 up to the top. I have no idea what that is. I'm going to guess that this is like an equilateral triangle. So maybe these are 12 and 12 as well. Maybe that'll help me. That would also kind of help me figure out the height. Equilateral triangles a little bit special. I can usually figure out some of the pieces that I need to. But right now, they didn't give it to me, so I'm not labeling it. Then I have this height going up the outside. It's actually a slant height. We were coloring that in blue before, so let's keep that consistent. So that's blue, and it's also equal to 8. So is this here. This is 8 as well. So those are the pieces that we have. Let's keep moving. There's other segments that we haven't labeled, but we weren't given anything more. Those are the pieces that we were given. Aha! We got a diameter of 16. Ooh, let's make it red. Diameter of 16. All the way across is 16. But then how far is it from the center just to the edge? Well, that's a radius. It's going to be half the diameter. That would have been 8. We use both of those a lot of times in these formulas, and sometimes it's good to know both. So 16 equals the diameter. That means that 8 equals the radius, which is half the diameter. All right, now this slant height here, this 23.4 is going to be our L, our slant height, and that's going to go here, 23.4. 23.4. So again, that's going to help us calculate surface area as we get into these problems a little bit later. Next, all right, what do we got going on here? This piece unfolds, but we don't know all the pieces. Let's label what we do have. This blue slant height, again, recoloring it blue, is going to be 24. That goes on the big triangle, so here this is going to be 24. Similarly, down here on the bottom, this is going to be 24 as well. Now the 33, that looks like it goes along the long side of the rectangle, so that side's 33 and that side's 33. And then the short side is going to be 14. The short side of the rectangle is 14. So we don't know this slant height that matches up with the 14. That's a question. We could figure it out with a lot of steps, but for right now, I'm not going to really mess with that. I don't need to. I don't have to. I'm not going to. Number 7. Ooh, do you see this faded piece here? I took this and I went ahead and made a net. So if you need to pause the video, here's the net that you need to copy. Go ahead and pause it if you need. Otherwise, let's keep moving on. So I'm going to use this net that I created. I knew that it was going to be that net because it's a pentagon and it's a prism, just like one of the previous problems we were looking at. I also know that this is a regular pentagon. If you look at that, I got all these markings all over the place, and that tells me it's a regular pentagon. So if one side is 8, that means all the sides are 8. Similarly, for this 10.6, that means those are going to be congruent slant heights all the way around the edge as well. So that blue line is going to match these blue lines, this 10.6, 10.6, all the way around. Excellent, excellent. Then we have this apophthegm. I like to color those purple. Why? Just because. The apophthegm. So that's going to go from the center of that base, which in this case is a pentagon, out to the edge. And that apophthegm in this case is 5.5. Why does that help me? Why do we care? We care because the area of this polygon, it's a pentagon. We don't have that like memorized, but I know that I could split any shape up into other shapes, and a regular polygon can be split equally into triangles, as I just did there with the gray lines. So splitting it up into those triangles, now I have these 5 triangles, and they all have a base 8 and a height 5.5. So to redraw that triangle, let's take a look at here. I'm going to kind of redraw this triangle. Let's make it, I don't know, green, just for some difference. So it fits kind of about there. So that green triangle, that's the piece that I'm going to pull apart over here. This green triangle, it has a base of 8 and a height of 5.5, and that triangle is in there 5 times. So I got 5 of these. Then I also have 5 of the triangles around the outside. And So if we were to make one of those, let's, I don't know, let's choose a different color. We'll do another triangle. So we got this triangle. Actually, let's not choose a different color just because I already made it. We'll rotate it so it looks like it fits in there. Is that pretty close? Hey, that is pretty close. Okay, so then we got 5 of these things. 5 of these taller triangles. So we got 5 of these also. This one has a height of 10.6 and a base again of 8. Well, it's asking us 2 questions. We've got to find the lateral area and the surface area. The lateral area is the area of the lateral piece, the parts that go around the outside of the pyramid. That's going to be all these kind of empty white spaces, triangles around the outside. Not the orange piece on the inside, but just the outside space. So the outside, the lateral, is going to be represented by these taller triangles, the lateral area. And that lateral area is going to be 5 triangles, because there's 5 of them, times 1/2 base height, which is each triangle individually. So I got 5 times 1/2 times, what's the base? Well, we think it's 8 there, and then the height is 10.6. So that's my lateral area. Now to find the inner area, it's just 5 of those inside triangles that make up the pentagon. Well, that's going to be 5 times 1/2 of those. 1/2, not 1/2 of those, 1/2 base height for those. Then we got 1/2, what's the base? It's 8 again, and then the height in this case is 5.5. We add those 2 pieces together, we get the total area, also known as the surface area. Check. Are we done? Yeah, because we don't have to simplify. You can if we want to. I'm not going to. Let's move on. Ooh, we got another net. If you want to pause it so you can copy this net, please do, because I'm not, and I'm moving on. All right, so I'm looking at this net. A couple of things I noticed. See this 9, 9, 9, all 9s all over the place. So that means this base is actually an equilateral triangle, this 9, 9, 9. It also gives me the height within this base, right here. The height of this base is 7.8. That's convenient of them to give that to me. Then I'm going to look at this slant height on the outside. I'm going to color it blue like we have been doing. And that's 11.3. So I got blue 11.3. Blue 11.3. And we got this blue 11.3 all the way around. So we got to figure out the lateral area, which is the outside pieces. Remember, the lateral area is this area that goes around the outside here. And the lateral area is going to be 3 of those triangles. Let's figure out how much each triangle is. So it's 3 times 1/2 times base times height for the triangles on the outside. That's going to be 3 times 1/2 times, what's the base? Well, in this case it's 9. And the slant height there, that L, is 11.3. So that's my lateral area. Now if I wanted to figure out my base area, which is here, the bottom, that's just one triangle, and it's 1/2 base times height, which is, in this case, I don't know, let's figure it out. Well, my base is 9, and my height is 7.8. That was 1/2 the base times the height for that bottom base area there. So this is the base area. Alright, so there's my total surface area. Surface area solved. Next. Okay, for this one, we have another shape coming up. Here's the net for it. Ooh, you know what? It'd be nice if these were not so orange around the outside. Let's fill those in with some white. I think I can actually just fill that in. Let me pause the video here real quick. Alright, so I filled in those areas like magic, and I'm already back. And now they're white around the outside, just to kind of even things up a little bit here. Alright, so we got this bottom base. What do we call that? It's got 6 sides. It's a hexagon. Not an octagon, but a hexagon. And it's regular. Notice that all these marks tell us that it's regular. All these angles are regular. That means it's well symmetrical and it's well balanced. It's easy to figure out the area of a symmetrical regular polygon. That means each of these bases are 6. So we got 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, all the way around. 6 sides, each measuring 6. That's kind of interesting. This apothem right here, going from the base edge to the center, is 5. So that's going to be 5. Oh, 5.2, pardon me. 5.2. And then let's go ahead and draw in some of these triangles for the base. So we know that it splits up into 6 congruent, symmetrical triangles. So we got the inside pieces there, and now let's look at the outside. We have this outside, this is 12.2. So it's going from the middle of the base edge up to each of these points. All those are going to be 12.2. So let's see what we're going to get when we add all this together. So those are 12.2. 12.2. There we go, 12.2. Oh, I forgot one here. There we go, 12.2. 12.2. All the way around, 12.2. So I know those are all 12.2. Let's find the lateral area, or the area around the outside here, around the lateral piece of it. Lateral area is going to be all those triangles. How many of them do we have? We got 1, 2, 3, 4, 5, 6 of them, which makes sense because it's a hexagonal pyramid. Okay, so we got 6 triangles. So 6 times, what's the area of just one triangle? Well, it's half base times height. Well, let's split that up now. Let's figure out what the base and height are. We know that it's going to be 6 times, well, there's the 1/2. What about the base? The base is this edge here, which is going to be 6. And the height was given to us as 12.2. Okay, that's our lateral area. Now let's find the inside area plus the area of the base. Well, the base happens to be split up into 6 triangles as well. So that's going to be 6 there, and then we have 1/2 base times height for each of those triangles. Well, that gives us a 1/2. We can multiply in there, and then the base in this case is 6, and the height is 5.2, as is given in the picture. So there's our total area. This equals our total area, or our total surface area. It's kind of implied when it says find the surface area that you have to find the total surface area, but just to be clear, that's what we're doing. We're adding up all the faces to find the surface area. Alright, now we're going to a square pyramid. Again, pause the video if you want to copy the notes. But I'm going to start labeling mine and see if what we can do here. We know that we have this square base, and it's a 4 by 4 base. We also know that we have a slant height here. This one's going to go pretty fast. It looks like that's 6.3. So I have the slant height that's 6.3. And it's 6.3 all the way around for each of these as well. It is for this one and for the other one. All right, so let's look at these outside areas, the lateral area, It's going to be 4 triangles. So I'm going to multiply it by 4, and then we got to figure out how much each triangle is. 1/2 base times height. So it's going to be 4 times 1/2. And what's the base of each of these triangles? It looks like it's 4. Okay, so that's 4. And then the height is 6.3. So that's my lateral area. Now let's look at that base area. Well, it's just a square. That's very easy to find. So the square is going to be plus 4, or plus 4 times 4, because that's the area of a square. There's our total area. That was super fast. We have the lateral plus the base. That gives us the total surface area. Next. Number 11. Did we make one for this? I don't know. Oh, there it is. Boom. Nice and big. There's the net. Alright, now notice again we have this pentagon. This is almost identical to what we did before, just the numbers changed a little bit. So we have this apothem. and that's 7.6. So I'm going to go from the middle out to an edge, and that's 7.6. And then if I were to split that inside up into, let's say, some triangles, we got triangle, 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 and then two triangles. Okay, so we have those triangles, and then we got this outside piece with a slant height. In this case, the slant height is 12.5. So I have that slant height, and that's 12.5. That's the piece that we're looking at. This is 12.5. So are these other ones as well. These are all 12.5. And then we got these edges are all 11. So let's go ahead and mark those maybe in black here. 11, 11, 11, 11, 11. So we start with the lateral area. Let's figure out what that is. The lateral area. We got 5 triangles. So I'm going to have 5 times the area of a triangle, which is 1/2 base times height. So it's going to be 5 times. Well, the area of one of these triangles, it's going to use the base and height here. The base is 11, and the height is 12.5. Now we're looking at the area of just the base in general, the lateral plus the base here. And this base is a pentagon, so it's going to be another one of these 5 times the area of a triangle, because we're splitting up into triangles as well. So we're going to add plus 5 times 1/2 times, what's the base for each of these triangles? Well, that happens to be 11. And what's the height? Well, that happens to be 7.6. That's our apothem. And that equals our total area. Total surface area. Excellent. We're almost done here. 2 more problems and we are done. Or maybe it's 3 problems. I don't even remember. Okay, so we got this pyramid going on. Let's look at this pyramid in real life, though, as a net. So there's our net. Ooh, we need to fill this. I figured out where these tools were. We need the fill tool. We're going to fill it with white. Boom, 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 boom. Done. That's pretty fast there. All right, so now we have this inner base and these outer triangles. We did this one very similar before. The picture even looked similar. So let's go ahead and change it around. Let's see what we got. So we got this slant height on the outside here. That's 11.3. So this slant height is going to be 11.3. And then we have the apothem height, which goes from the middle of the base out to the edge of that regular polygon there. So it's going to go from the middle of the base out to an edge. And then we got all these base edges, which are 6. So we got 6, 6, 6, 6, 6, and 6 again. Okay, wow, that's kind of interesting because that's what it was last time. These 6-sided figures, each measuring 6 around the outside. Is kind of a weird pattern. All right, so we got that. We didn't label the actual value of the apothem here. This is 5.2. So 5, let's write that in purple. 5.2. Let's go ahead and make this split up into triangles just so we can see what we're dealing with. Now we got these 6 triangles. All right, so let's start with the lateral area. The lateral. Well, let's start with a regular pen. How about that? Lateral area. Well, the lateral area is going to be 6 triangles. So that's 6 times half times the base times the height. So that means we have this 6, because there's 6 of them. And we have the half. Now we need the base and the height of each of those outside triangles. That's this one and so on. Well, that height is 11.3. That slant height was given us. And the base, oh, you know what, let me, just for consistency here, let's put the base first. The base is 6, and then the height, like we were just saying, is 11.3. So that covers our lateral area, the part that goes around the outside. That's our lateral surface area. Now we need the base area as well, so we got to add the base to that. So we're going to put plus. Now this base is a series of 6 triangles. So I'm going to put 6 triangles here. That's 6 times half times the base times the height of those inside triangles. So we have a 6, then we have a half, and we need to multiply a base and a height in there as well. Well, the bases, again, are 6, and the height is 5.2. There we go. And that is our total surface area. Total surface area. Excellent. Ooh, this one doesn't give you a picture at all, but I drew one, at least the net, just to show you guys what we're looking at here. This is a pyramid with a slant height whose triangular base. So notice that I just made a triangular base and I made a pyramid, which means I make triangles out of each of the other edges. So I have a triangular base, and it's 11 on each side. So this is 11, 11, and 11. And each altitude of the base measures 9.5. So what that's saying is this piece here. This is 9.5, no matter where it was coming from. And the slant height is 6.8. So how do I calculate this area? Well, it's always the lateral area plus the base. So let's start with the lateral, and then we'll add the base to that. So if I am multiplying or adding, pardon me, the lateral area is a series of 3 triangles. So we got 1, 2, 3 triangles. So it's going to be 3 times 1/2 the base and height of those triangles. So we have 3 of them times 1/2 for the triangle formula. The base of each of these is 11, and the height is 6.8. That's slant height. That's where we get that from. That's that L, slant height. Now if we're adding the base to that, the area of the base is pretty straightforward. It's just a triangle, so it's 1/2 base times height. So we're going to add 1/2. The base of this triangle is 11, and the height is 9.5. Check. Done. Dizzle. Moving on. This is the total surface area. If we add those together. Last one. Here we go. A rectangular base. So something to notice about this is it's a rectangular base, not necessarily a square base, but a rectangular base. Whoa. I meant for those to be kind of grouped together, but let's go ahead and fix them. So we got to ungroup these. Move this. Ungroup them. Move that one here. Shrink it down a little bit. And move this one there. Shrink that down. Alright, so there we go. That looks a little better. So we got a rectangular base measuring 4 and 9 inches along the base. So this is 4, this is 9, this is 4, and this is 9. With slant heights 10.1 and 9.2. So the longer ones are going to be 10.9 or 10.1. So that's going to be these ones here. Those are going to be the first ones. So this is 10.1 for this triangle. And this is 10.1 for this triangle. And then 9.2 for the others. Now you might be wondering, how do I know which ones were shorter than others? Because they look pretty much the same. Well, it's kind of an interesting way to think about it. It has to do with the Pythagorean theorem relationship and how far they are from the center of this base. And if you think of one side of the pyramid as being further away from the center than the other side of the pyramid, well, this line is going to be definitely, see how this is a short distance from the center and a long distance from the center. The further you are from the center, the longer you are going to be for your slant height. So the short slant height comes from a short distance from the center. So the short distance from the center here is going to have the short 9.2, while the longer one has a 10.1. So as we're moving on from this, let's see if we can find the lateral height. Well, the lateral height this time, it's not just 4 triangles. We got 2 long ones plus 2 short ones. We got the long and we got the short. but they are triangles, so it's just going to be half base times height and half base times height for each of these. And then we're going to add to that the area of the base, which is just a rectangle, so it's going to be plus base times height for that. So let's start out with the long ones, which would be these ones on the left and right. These are the long. Okay, so the area of those is going to be 4 times 10.1 for the base and height. That's 2 times 1/2 times 4 times 10.1. Now the short ones, this one's short and this one's short as well. It's going to be 9 times 9.2. So it's going to be plus 2 times 1/2 times 9 times 9.2. And we're going to add to that the base, the area of the base, which is very easy. Just base times height, which is 4 and 9 multiplied together. And that's it. That's the work for these. Some of them are harder than others. Go back and watch it again and again and again until you get it. Thank you and have a good night.